Hello students, myself Navneet Patel. So today we are going to discuss with the electron gain enthalpy or electron affinity. Okay. So as you know, in previous video we have to discuss about the ionization potential. In ionization potential, then the energy is required to remove an electron from the outermost shell of any gaseous atom. That means when we remove an electron, then energy is required. In opposite word, the energy is released when an electron is entered in the outermost shell. So that is why, according to the electron gain enthalpy, the energy released from an isolated gaseous atom when an electron enters in the outermost shell of isolated atom. Okay, isolated atom or isolated gas atom. Okay, students, that means when an electron is entered in the outermost shell of an atom, then the electron energy is released. This energy is known as the electron enthalpy or electron gain enthalpy or electron affinity. Okay, students. So basically, take one example. Suppose X is an element and an electron enters in the outermost shell of an atom. Then the energy involved during the process, this energy is known as the electron enthalpy. When an electron enters in the neutral gaseous atom, then it converts into the anion. This is the anion. Okay. In the formation of anion, the energy is released during this process. This energy is known as the electron affinity or electron gain enthalpy. Okay, students. Now take another example. Suppose chlorine atom. In chlorine atom, you know very well atomic number of chlorine and 7 electron in the outermost shell. According to the electronic configuration, here look here, 1s2, 2s2, 2p6, okay, 3s2, 3p5. Look here, total 7 electrons here. But according to and last electron, 7 electrons is here. So when one electron enters in the outermost shell of chlorine, suppose this is the outermost shell, this is the K shell and it is L shell, it is M shell. In M shell, when electron enter in M shell, then chlorine atom which is neutral, it converts into the anion, that means the Cl minus N. In this process, the energy is released from the atom. This energy is known as the electron affinity or electron gain enthalpy. Okay, students. So basically, you can say electron gain enthalpy is the endothermic process or exothermic process because the energy is released. That means this process is known as the exothermic. But some conditions are there. Suppose if next electron, suppose in another electron enter in the Cl minus atom, in this case, then the entered electron repels another electron. Okay, so that is why in this case, in this duration, the energy is not released from the atom. Energy is required to enter the electron in the outermost shell of atom, and this enthalpy is endothermic. This is exothermic process, and this is endothermic process, and it converts into the Cl minus 2 ion. It is endothermic. Okay. Now in this case, this electron affinity is known as the first electron enthalpy, and second electron enthalpy is known as the second electron enthalpy. Okay, students. Now we take variation of electron affinity in the periodic table. Okay, now next we can take another variation of electron gain enthalpy or electron affinity in the periodic table. Okay, now look here. Suppose it is the periodic table. It is the periodic table, and these are the periods. Okay, students. If we move left to right in period, then atomic radius decreases. If atomic radius decreases, then if electronic radius decreases, then the entered electron is so difficult. Entering of the electron, that means when we enter an electron in the outermost shell of atom, it is difficult process. So that is why electron gain enthalpy is more. In general case, not in all periodic table. In general, you can say electron enthalpy is inversely proportional to atomic radii, okay, or atomic size. That means if size is decreases, okay, then in this case electron gain enthalpy is increased. That means both are the inverse relation. Okay, so finally you can say when we move left to right in periodic table, then atomic size decreases. That is why electron gain enthalpy or electron enthalpy increases. Okay, in groups, suppose when we move up to down in the group, then atomic radius increase. If atomic radius increases, then electron gain enthalpy decreases. Okay, we are going to discuss about the topic electronegativity. As you know, electron affinity and ionization potential, the energies involved in both processes. But this case is different than the other. Okay. So basically, what is the electronegativity? It is the tendency. It is the tendency of an atom to attract the electron from the outermost shell of the another atom. Okay, so this tendency is known as the electronegativity. That means tendency to attract the electron from the outermost shell of any another atom with of element. Okay, that means it is the tendency to attract an electron from the outermost shell of any another atom. This tendency is known as the electronegativity. You can say in other words, the capacity of an atom to attract the electron during the process of chemical bonding. Okay, look here, take an example. Suppose it is a molecule SCl. In molecule of SCl, here two atoms. First one hydrogen and second one is chlorine. In the case of hydrogen chloride molecule, hydrogen contains in one electron in the outermost shell, and chlorine atom contains the 7 electrons in the outermost. Okay, students. Okay, you know very well the atomic number of chlorine is 17, and atomic number of hydrogen is 1. Okay, so you know here 17 photons to attract the 1 electron from the chlorine atom. This attraction force towards the chlorine atom, this attraction is known as the electronegativity. Okay, that means those elements which have tendency to attract the electrons, such type of the elements are generally non-metals like chlorine, fluorine, iodine, extravine, phosphorus, sulfur, oxygen. Okay, another example, some example are there. Suppose in 15 group, okay, 15 group sulfur. You know atomic number of sulfur 16, and how many electrons present in the outermost shell of sulfur? 6 electrons. Suppose 6 electrons is here. Okay, so sulfur atom, suppose point for the hydrogen, and 1 electron is there. sulfur molecule attract the both electrons from the hydrogen and they form the bond H2S. Okay, okay students. So this attraction force towards the electropositive element to the electronegative elements, this attraction force is known as the electronegativity. Okay, now we will discuss the variation of electronegativity in periodic table. Okay students, so look here, suppose it is the periodic table. Okay, this is the P block and it is D block, P block and S block. Okay, it is roughly. Okay, now look here, if we move like this, if we move left to right in periodic table, if we move left to right in periodic table, then atomic radius concentrated, that will decrease. In this case, electronegative power will be increased. Why electro power will be increased? Because the radius will be short and the nuclear charge will be increased. Okay, like this. Suppose in this group, first group, that means the hydrogen family, earth alkali metals, and second one is alkali earth metal. And now in P block, first case is boron family, 13 group, boron family, 14 group, carbon family, 15 group. In 15 group, nitrogen family. In 16 group, oxygen family. In 17 group, that is known as the halogens. In first halogen is fluorine. Okay, in 18 group 0. Okay, so when we move left to right in periodic table, in periods, in this side, the atomic radius decreases. That is why electronegativity will increase. So you can say the electronegativity power leave this stage because the noble gases do not take part during the reaction because the outermost shell are completely filled. Okay, these are the stars. In this case, suppose 15, 16 and 17. So electronegativity power of fluorine, is greater than oxygen, is greater than nitrogen. Okay, now if we move up to down in the periodic table, suppose we move in a group, any group, suppose you know very well, here nitrogen, phosphorus, bismuth, antimony, bismuth. Okay, these are the elements. Okay, now in representative elements or P block elements, look here, if we move up to down in the group, in this case atomic size increase, that is why electronegativity will be decreases. Okay students, because atomic size increases, electronegativity will be decreases. But in the period, when we move left to right in the periodic table, the atomic radius decreases, that is why electronegativity will be increased. Okay, now suppose in whole periodic table, these are the elements, that is the halogen elements, and these elements having the highest electronegativity power of the other elements, and in these elements fluorine is having the highest power. That means fluorine is the most electronegative element in whole periodic table. Okay, so in case of the fluorine, bromine, iodine and astatine, so electronegativity power of fluorine is greater than chlorine, is greater than bromine, is greater than iodine. Okay students, so in the group, when we move up to down, the electronegativity power will be decreased because of the atomic radius will be increased. So you can write here, suppose electronegativity inversely proportional to the atomic size. In general case, not some special case are there. Okay, you will study in the higher class. But in general, you can say when we move up to down, then the electronegativity power will be decreases. Okay. Now our next topic is metallic character.